Hello everyone. Today we'll be discussing a very interesting lead code question, medium level question. It is related to DP, and the interesting part here is the solution is not that difficult. The naive solution is not that difficult. It can be figured out immediately. But yeah, the optimized one is a very interesting approach. So we have to find the largest divisible subset. I'll quickly explain what is the largest divisible subset. So the largest divisible subset in an example of, let's say, 1 2 3 9 is 139. How is 139 the largest divisible subset? Because we choose any pair of elements, let's say 1 3, either of them divides each other completely, like 3 1 divides 3 completely. So 3% 1 equals to 0, and 9 3 has the same equation, like 9% 3 equals to 0. 1 9 is having the same equation. So yeah, this is how it becomes the largest divisible subset. Even 1 2 is a divisible subset because 2% 1 equals to 0, but this is not the largest one. So that's what we call the largest divisible subset. Now next up we have I'll come up with the solution. The solution, which I think anyone can figure out. It is very straightforward, where we have 1 2 3 9. We see the first element, we append it. See the second element. This is the answer element for now. Answer list for now. We see the second element. We compare it with all the elements in the answer array already. So 2% 1, is it divisible completely? Yes, it is. So we'll have a new value appended to this, that is 1 2, and at the end we'll append the element itself. This is the answer element now. Now when we see 3, we'll do the same for all the elements. We'll see, is 3 divisible by 1? Yes, it is. So we'll add another element, that is 1 3. Is 3 divisible by 1 here? Yeah, it is. Is 3 divisible by 2 here? No, it is not. So we'll not append it to this particular element. Is 3 divisible by 2? No. So we'll not append it to this particular element as well. Now we'll append just the 3. So now the new answer list is this completely. Now same we'll do for 9, and at the end we'll find that we have the element 139 somewhere in this answer element. So we'll have to find which is the largest element within this, and we'll have to return it. So this is a naive approach, which for me went up till n to the power 3, because there were 3 loops. One loop was iterating over this, the other loop was iterating at the on the answer list already existing, and the third loop was basically comparing the current element to all the elements of the answer list. For example, there is this element 1 2, so 3 was comparing, the third loop was comparing 3 with 1, then it was comparing with 2, and if it was satisfying, then it was appending 3 to this particular element. So yeah, it was going up to n to the power 3 in the worst case. So I was about to get the answer, but for the last three test cases, it basically ran out of time. So yeah, and that's there. But the optimized solution is, in the lack of a better word, I would say, is beautiful. 1 2 3 9. So what happens over here? Here um, we basically update the answer for this current element. So that's the approach for DP in most of the case. But yeah, figuring this out here was a little tricky, in the sense, like, let's say we first sort the nums whatever is given. Let's say it was 2319. We'll sort it so it will become 1239, and now we'll create a answer list in which we'll append each element once as a list, like 1 2 3 and 9. They all are list in itself. So that's there. Now we'll start a loop I over this, and we'll start a loop j which goes up till I. So like, let's say if I is at 2, it will run for this element. If it is 3, it will run for 1 2. So it is going up till I. So what happens is, we see 1 j, there's no element before 1, so it just remains 1 over here. In the second iteration of I, we see 2, and we see whether 2 is divisible by jth element. 2 is divisible by 1? Yes, it is. So what will happen is, we will append 1 to 2. Why do we do that? We see whether 2 is divisible by 1. It is. Then we see what is the value, what is the answer at 1. It is 1. It is already 1. And we compare one more thing. The current answer at 2 is, the length of current answer is just 1. It is just 2. Okay, so we'll see whether appending 2 to this answer makes it greater than the current answer. It is, because just 2 is not greater than 1 comma 2. So we will append 2 to this particular value and we will append the answer over here. Okay, now since the J loop ends, now we go to the third element with I. So I is here now. We check whether 3 is divisible by 1. It is. Now appending 3 to this answer, is it greater than the already existing answer? That is whether length of 1 3 is greater than length of this. Yes, it is. So we will update this as well. Now we will do the same for 2, whether 3 is divisible by 2. No, it is not. So the J loop ends here. Now we go to 9. Now for 9, what we have to do is we again have to start comparing it or dividing it by previous J's. 9 divisible by 1. Yes, it is. Okay, first condition pass. Now 1 comma 9, is it greater than the current answer of 9? Yes, it is. So we operate it as 1 9. Now 9 divisible by 2. No. The next J is 3. 9 divisible by 3. Yes, it is. Now we see what is the answer at 3. It is 139. So we go, we take 139, appending 9 to the current, to this answer. Is it making it greater than the current answer? Yes, 139 is greater than the current answer 19. So we update this value to 139. And this proves out to be the greatest element. Now answer is at the end updated to this, and we have to find which is the greatest element in this. That for that we can create a lambda function. Quick lambda function will do, and that's what I've done here, and this gives the solution. And yeah, this is the most optimized solution in n square time complexity. One loop is for I, the other loop is going up till I. So that is basically 1 plus 2 plus 3 plus arithmetic progression whose sum we know is n square, and of the order of n square. It is n square by something, but yeah, it is of the order of n square. So yeah, this is the solution, and yeah, it's actually interesting, and it was damn tricky to figure it out. So thanks a lot.